Okay, here's a video on distance on the coordinate plane, or the Cartesian grid, and the Pythagorean theorem. Okay, so we can get the distance on the coordinate plane using the unit boxes when we go up or down, but when we go diagonal, we need the Pythagorean theorem. So let's just review the Pythagorean theorem. A squared plus b squared equals c squared. Let's put it squared there. And there was another formula, the same formula, but another way of doing it. If you remember, we did the square root. A squared plus b squared equals c. So whatever one is you're more comfortable with. A lot of students think this one's easier, but it's up to you. It's up to you. Okay. Now, one thing we should know when we're doing the Pythagorean theorem, and it's used again when we're working with right triangles. Now here's something we should remember. If the Pythagorean theorem does not work, if it does not work, then the triangle is not a right triangle. Or you made a mistake multiplying. So if the Pythagorean theorem does not work, it's not a right triangle. So if you saw the right, let's say you saw something like this and you didn't see the box, and we had a 3, 4, 6. Now, if this doesn't work, we know, and you know this doesn't work because the 3, 4, 5 is the Pythagorean triple. But let's say you saw a 3, 4, 6, and I asked you, is this a right triangle? So again, you would say, we can do this way. We can say 9 plus 16 equals 25. And the square root of 9 plus 16 is the square root of 25, which is 5, that is. And we know that it's 5, not 6. So this is not a right triangle. Let's do another one. Okay. So let's make a triangle. And we'll determine if it's a right triangle. What if I had 2, 8, 11? Is that a right triangle? Now, you can just look at this and know it doesn't. If you look at the base triple, the 3, 4, 5, remember, always look at the 3, 4, 5. How can we get 2? How can we get 8? How can we get 11? So 5 times 2 is 10. 4 times 2 is 8. So you know right away that this is not a right triangle. If you remember last video, we did the Pythagorean triples. But again, if we did 2 squared plus 8 squared, will this work? A squared plus b squared equals c squared. Okay, so we have 4 plus 64. Does that equal 121? No, it does not equal 121. So this is not a right triangle. So remember, we can use the Pythagorean theorem to check if it is or isn't a right triangle. So let's find some distance. So here we have a right triangle on the coordinate plane. And this is A, and A is -2, -1. Make that bigger for you. And B we have is 4, 7. So here we can find C. What do you think C is? So you just count. 1, 2, 3, 4. So this is 4, -1. So now, as I said before, we can count distances using the unit boxes, if we go left or right or up and down, right? So we can go, this is 1, 2, 3, 4, 5, 6. So that's a 6. And we can go up and down, we can count. That's 1, 2, 3, 4, 5, 6, 7, 8. So that's an 8. So we're missing C. And again, you can use the Pythagorean theorem, or you can use Pythagorean triples using the base. And do you remember what the base was? The base is the 3, 4, 5. Okay, so if we look at this, and again, this could be A or B, it doesn't matter. We know that 3 times 2 is 6, and 4 times 2 is 8, so 5 times 2 would be 10. So the distance from this point to this point would be 10, using the Pythagorean triple. Now do it using the Pythagorean theorem. So we know it's going this way now, and we had that is 8, and that is 6. So we're trying to find C. Bring this up. So we can say 64 plus 36 equals 100. So that's a squared plus b squared equals c squared. And the square root will give us c, which is 10. Let's do a few more. So what if I gave you these 2 points? We have a negative 2, 3. I'll make it bigger. Negative 2, 3. That's that point. And this point is 5, 7. Now, first we have to make a triangle. So you can make it, well, you can make one here if you want it. All right, and then we just need to find what the hypotenuse is. What is the diagonal? What is the distance between this point? We'll call this point A, and we'll call that point B. What is the distance? Try to do that. Well, first we need the sides. We need to know what the sides are. So from this point, we got 1, 2, 3, 4. That's a 4. So that's 4. And what about here? 1, 2, 3, 4, 5, 6, 7. That's a 7. So now we need to know, what is this distance here? So we're having 4 squared plus 7 squared. Will that give us, what will that give us? Try that. Okay, so we have 4 squared. This is 16. That's 49. So c squared will be 65. So c, and you can put this on a test, will be the square root of 65. That would be the answer. The square root of 65. Okay, try this one. Let's make a right triangle, and we'll make it where this is the point. Find all the sides. Okay, so we can make a line here. We can count the distance from here already. 1, 2, 3, 4, 5, 6, 7. That's 7. And we can count the distances on this one. We have 1, 2, 3, 4, 5. And there's our diagonal. Okay. So we have a squared plus b squared equals c squared. And we know that you can use either one. We say we'll make a 7, so we'll have 49, and b is 5. And that could be a, doesn't matter. 25 equals c squared. Okay. So if you add this together, c squared will be 74. So c will be the square root of 74. Make that better. Square root of 74. Let's write that better. Square root of 74. Alright, so that's how we can use the Pythagorean theorem on the coordinate plane. Remember, we're only trying to get the diagonal. We can get the up and down lines using the unit boxes. Okay, great job.